بسم الله الرحمن الرحيم وبه نستعين. الفيديو ده بيتكلم على جزء من يونت 1 chapter 4 alternating current and capacitor C. What is the capacitor? A capacitor is two metallic plates insulated from each other, used to store electrical charges. Two metallic plates insulated from each other, used to store electric charges. Capacitor law. Capacitor law. Q, which is the amount of charges between the plates of the capacitor, equal C, which is capacity of capacitor, multiplied by V, which is the potential difference between the ends of the capacitor. Q, which is the amount of charges between the plates of the capacitor in coulomb. C, which is the capacity of the capacitor in farad, and V, between the potential difference between the plates of the capacitor, is volt. Why the capacitor doesn't pass direct current? Why the capacitor doesn't pass direct current? If the two plates of the capacitor is connected to a cell, now the potential difference between the plates of the capacitor is zero. A current pass from the source to charge the plates of the capacitor with a potential difference. If the plates of the capacitor have a potential difference more than the source, the current will stop. طيب why بقى the capacitor pass the alternating current? At the beginning, when the potential difference between the source is high, the electric current will pass from the source to charge the plates of the capacitor. This happened in the beginning of this half cycle. When the potential difference between the plates of the capacitor more than the potential difference of the source, the capacitor start to discharge again. So the capacitor charge and discharge during a half cycle. In the second half cycle, the capacitor will be charged again, but in opposite direction. So the capacitor is charging and discharging through a half cycle of the alternating current. Here we have two graphs, one in blue, which indicate the potential difference between the plates of the capacitor, and the other in violet, which indicate the current passing to the capacitor. We observe here that in the beginning the potential difference between plates of the capacitor is zero and the current is high, so the capacitor charge start to be charging till the potential difference between the plates of the capacitor is maximum. The capacitor start to discharge again, so the capacitor is charged and discharged through a half cycle. In the second half cycle, the capacitor will be charged and discharged, but in opposite direction. Here we will observe that at the beginning the potential difference of the capacitor is zero, and the current is maximum. So current leading potential difference between plates of the capacitor. So the current leading potential difference between plates of the capacitor by an angle equal 90 degree, which is 1/4 cycle or 1/4 periodic time. V instantaneous between plates of the capacitor equal V maximum sine omega t. I instantaneous between plates of the capacitor equal I maximum sine omega t plus 90. So here there is a phase difference. Current leading voltage by 90 degree. Current here leading voltage by 90 degree. I leads V by 90 degree or by 1/4 cycle or by 1/4 periodic time. The capacitive reactance Xc, it is an opposition due to existence of a capacitor in AC circuit. The capacitive reactance Xc is an opposition due to existence of a capacitor in an alternating current circuit. Calculations Xc, which is the capacitive reactance, equal 1/2 pi frequency C. Pi here is 3.14 and the frequency is F is the frequency of the alternating current, and C is the capacity of the capacitor in farad. So capacitive reactance Xc will equal 1/omega C, where omega equal 2 by frequency, which is the angular velocity of the variation of the alternating current, and C is the capacity of the capacitor in farad. Current, which is effective, equal V potential difference between plates of the capacitor divided by the opposition, which is here capacitive reactance Xc in ohms, of course. Unit capacitive reactance in ohm and frequency hertz -1 لأنها تحت، وبعدين فراد -1. C is the capacity of the capacitor in farad، يبقى الأوم equivalent to hertz -1 farad -1. Total capacity of several capacitors. Look here, we are calculating capacity, not capacitive reactance. We are here calculating capacity of several capacitors. If these several capacitors connected in series, 1/, total capacity of the group equal 1/, capacity of the first capacitor plus 1/, capacity of the second capacitor. So reciprocal of the total capacity of group of resistors, of group of capacitors connected in series equal the sum of their reciprocals. يعني 1/, C total equal 1/, C1 plus 1/, C2. If we have a group of capacitors which are equal to each other and connected in series, the total capacity of this group of capacitors connected in series and which are equivalent to each other equal capacity of one of them divided by its number n. The capacitors, if the capacitors connected in parallel, so total capacity of the group of capacitors connected in parallel equal the capacity of the first capacitor plus capacity of the second capacitor. If we have group of capacitors connected in parallel and they are equal in capacity, so its total capacity will equal capacity of one of them multiplied by its number n.